So first I'll say thank you to the HT Solutions team for having me here today. It's a great event. Also, like some of the other speakers, my first time here in Georgia. Really enjoying it so far. Great to have an opportunity to meet so many people. My presentation is going to be a little bit different on a topic than, a different type of topic than most of the other presentations here today. But I do appreciate the opportunity to talk about what Nozomi Networks does and look at some of the examples for the types of implementations that we do. So just for a quick introduction first, Michael Dugent. I'm the director for IoT for Nozomi Networks for Europe, the Middle East, and Africa. As an organization, Nozomi Networks is focused mostly on operational technology environments. I'm focused on finding projects and verticals outside of the core operational technology focus. Long background in cybersecurity for industrial control systems. I spent 10 years at one of the first startups for cybersecurity in this space. I also worked for U.S. defense contractor Lockheed Martin in a commercial cybersecurity practice focused on oil and gas, and worked as well with some behavior and analytics startup. Just a quick introduction to Nozomi Networks. As I said, we're focused on cybersecurity for industrial control systems, IoT, basically any type of environment that isn't going to be covered by a traditional IT cybersecurity technology or capability. We were founded in 2013. We've grown very, very rapidly, founded in Switzerland, based in Switzerland, and now monitoring close to 60 million devices on 6 continents across 5,000 installations. So before I get started on the actual presentation and looking at some of the, the basic outcomes and results, what I wanted to go over first was just a brief overview of the basic functionality of the Nozomi Network solution, because I know for a lot of you this will be relatively new. What we're focused on is basically taking mirrored traffic from unique environments and using deep packet inspection techniques to find out as much information as we possibly can about those environments. So we're looking at, again, non-standard protocols. In industrial environments, that could be something like Modbus or Profinet. It could be IoT protocols like Zigbee or MQTT. Its devices that we're looking for are like PLCs, RTUs, cameras, not traditional IT devices. And what we're hoping to do is give a simple, we lose the mic? Oh, good. A simple solution for finding these devices, identify what they are, who they're communicating with, whether they're communicating with the devices they're supposed to be communicating with, and finding out as much as we can, even about the industrial process itself. So first we provide that visibility. We then use the information that we've uncovered about the assets and about the networks to detect cyber threats through a combination of vulnerability identification, signature and indicator-based threat detection, as well as anomaly detection. There's a machine learning capability built into the product that is automatically learning all of the device information, all of the communication flows, even down to the function code and variable level, understanding the industrial process and detecting anomalies on that traffic once it's happened. And then we scale. Most of these implementations are in very small environments like substations to medium-sized environments like manufacturing facilities. So there's a lot of implementations in smaller environments, but it can scale up to tens of thousands or hundreds of thousands of devices. So we give a way to unify that data in both on-premises solutions and via a cloud solution. So just a high-level overview of what we're doing. And then a look also at the verticals that we focus on. So typically we start with pure play operational environments. This was the only thing we focused on for the early parts of the company. Think oil and gas, electric, mining, water, pharmaceutical, chemical manufacturing, a lot of implementations in this space. We're working today with 7 of the world's 20 largest oil and gas companies, 5 of the world's 10 largest mining companies, the world's largest automobile manufacturer, the world's tallest building, the world's largest mall. These are the types of projects that we're working on. We also work in what we consider more hybrid or pure play IoT, so building automation, airports, smart cities, military, hospitals, think medical technology devices. And I have some examples, and we'll look at those as we go through example architectures. So just a, again, high-level look at a sample deployment architecture. I'm going to look at one that's operational, and I'm going to do another one focused on IoT. In an operational environment, you tend to have what's called the Purdue model, which is a network segmentation that's focused on isolating the critical assets, the industrial assets, from the business networks and the internet. And the way this model typically works is that the communication flows can only flow one level up or one level down, so that you don't have PLCs or RTUs talking directly to DNS or talking directly to the corporate network. The Nozomi network solution is meant to be deployed down at the level 1 control network, the level 2 process network, to find out information about the devices that your normal IT security tools aren't typically going to be looking at, aren't going to be focused on, and in some cases, most IT teams don't even know these devices exist. It's like a window into the really dark environments that aren't really focused on for monitoring, but are often the targets for nation-state level attackers when they're working on or targeting these types of organizations. And now a sample architecture for IoT. In this case, I used a hospital just because of the wide variety of types of devices. This example is going through the actual use case of a user or a patient, in some case, going through the process of entering a facility all the way through checkout and exit. And what he liked to focus on is all the different types of devices in these environments that you wouldn't typically be looking for with standard IT security solutions. So everything from parking, the safety cameras, parking sensors, parking meters, through the entrance doors with digital signage, check-in kiosks, all the way up to the medical technology devices. Through the checkout process, there's going to be cameras, there's going to be HVAC systems, vertical transportation, think elevators, escalators. These are the types of environments that, with the Nozomi Networks monitoring solution, we want to find and provide cybersecurity and visibility for. So with that, what I want to do now is talk about some high-level use cases for why you would want to monitor these environments and what you would typically be looking for in them. So first, why monitor OT and IoT devices? If you think about a power generation facility or an oil refinery, most of these networks are assumed to be completely segmented or isolated in some way from the internet or from corporate networks. And maybe 15, 20 years ago, that was maybe a little bit closer to reality. But as connectivity continues to increase, and as more connectivity technologies and capabilities become available, it's more and more likely now that these devices or networks have communications, at least into the corporate network, and through there's the opportunity for attackers to pivot into what are supposed to be these really unique critical environments that they shouldn't have access to. In many cases, organizations believe that these networks are completely segmented or isolated with an air gap, and that doesn't always turn out to be the case. And it is possible for attackers to reach air gap networks through USB stick transfers or rogue employees, things like that. So understanding what you have in these environments is absolutely critical, and especially because if these types of devices are compromised, we're not talking about your email going down, or we're not talking about not being able to reach the internet. In many cases, these are controlling a process that could involve physical damage if it stops working, or could involve the lights going out in a major metropolitan area. So the criticality is incredibly important, and that's one of the things that we like to evangelize as we look at different industries and look at different environments that we haven't been before. It's the security by obscurity approach, by hoping that people won't find and won't know how to use these devices, is no longer relevant. So one use case to focus on first, operational visibility. So what I'm showing up on the screen here is an example of the identification of a Rockwell Allen Bradley PLC. What you need to be focused on first is, of course, understanding what devices are on the network. This solution is passive, and most solutions targeting critical environments should be passive first. So you take span data or use a network tap, look at the traffic in the network, but not put something in line so that you don't break something when you're starting the monitoring process. To get that initial visibility, use deep packet inspection to uncover as much about the devices as you possibly can, and then automate as much of that process as possible. So in this case, the screenshot there is of a ControlLogix PLC. We see the serial number, we see the firmware version, we see that there's vulnerabilities identified with it, and all of that information was caught passively using the deep packet inspection techniques. a second use case here for hybrid threat and anomaly detection. This is after you've uncovered the devices, you get a visibility, you get a picture for what devices exist in the environment. This is taking us a deeper look at saying, okay, now that we know what devices are present, how do we know if they're under any type of threat or if they're operating normally? This is one of the advantages of monitoring these environments from a cybersecurity perspective is you get value that's not necessarily cybersecurity specific. If you're monitoring the communication, the function codes within an industrial process, if you're monitoring the variable information, you can even get operational information to see things like, is this turbine spinning faster than it normally is, or are we seeing connections to a device that are coming from outside of an environment that really shouldn't be communicating with it, that could indicate that it could be that the device is about to fail. And one interesting use case we use is we have a customer that's in the entertainment business that uses this process to monitor the PLCs that control a roller coaster, and they're able to say, now that the PLCs are being monitored for these values, and we know that we can start to see when it's beginning to fail, we can actually shut the ride down overnight instead of while there's guests in the park. It's not really a cybersecurity challenge, but it's an operational one that brings value. So in this case, look for a solution that has the ability to uncover not just the industrial protocols themselves, but get down to the variable level and detect changes in that. So the screenshot that I'm using here, this is showing a Modbus process. We've identified a minimum value for the process here, a maximum value, the flow rate, and what we're seeing here is that there were values injected at the end of that process there that are well outside of the range that had been identified and learned. So that's actually indicating an anomaly in the industrial process itself. So what I want to get to now is just kind of the more fun part, right? What are some of the things that we find when we start to do implementations in a substation or in an oil refinery or an environment like that? All via screenshot. So first, this is maybe not something you would think about in an IT environment as a problem, but is a very big deal often in critical infrastructure, which is devices that are connected to the internet. Again, in most cases, the expectation is that these devices are completely isolated. Yet in probably close to 50% of our implementations, we not only see that there's a path for the critical infrastructure devices to have access to the corporate network and the internet, but we often find connections directly to the internet from these environments themselves. I wasn't there for this one, but I even heard of an example of a power plant control room having overnight operators that would just get bored overnight, so they didn't think it would be a big deal to plug a wireless access point in and actually play World of Warcraft from the operating environment. Very often, one of the first things we identify, one of the first things we look for is there's a view that we can select to say, we just want to see public IP addresses or communications passing the firewall that shouldn't be, and this is one of the first things we detected. So the screenshot is showing basically everything in red there is a public IP address. I'm just zoomed in on it here so you can see it a little bit more easily. A wide variety of OS and firmware versions. So in this case, there's obviously Windows devices. I'm sure you might get some chuckles seeing Windows XP. Critical infrastructure environments don't get updated very often. I still today in 2022 will go into a power plant and see pre-2000 Windows installations. We'll go in and we'll see devices that haven't been updated in 15 or 20 years. This is very, very common. But at least understanding what is there, you can understand the ways to isolate and mitigate some of the potential problems, even if there's no patches coming anymore, or even if there's no legitimate cybersecurity techniques you can use. In this case, I also like to focus on the Allen Bradley PLCs again. So there's about 6 different Allen Bradley PLCs there, and we see that the firmware versions of those are varied. Most of the time, these are implemented together, but when they get replaced, or when there's some type of upgrade on the system, or if there's some type of replacement that needs to happen of the PLC or the PLC firmware, it doesn't all happen together, and you start to get a mixed match of different firmware versions out there, which makes securing the devices a lot more difficult from a mitigation perspective. This is software vulnerabilities. Again, in many cases, we're not dealing with updated systems. We're dealing with old versions of Internet Explorer. In this case, we're seeing vulnerabilities with OpenSSH, with Chrome. Again, maybe not so easily updated if it's not possible, but at least understanding the vulnerabilities gives the end user an opportunity to put other mitigations in place to prevent these from being exploited. Software and firmware vulnerabilities with the Rockwell Control Logics PLC. Again, this is just a deeper look at it. So you can see we list out the vulnerabilities, we list out the CVE score, again, to have an understanding of what's potentially vulnerable. In this case, again, this is all passive detection of the device. We're able to pick up even the components that were plugged into the PLC, so we can see if they're the firmware version and if there's vulnerabilities with the redundancy module, communications adapters, all the little components that might be plugged in, talking to the devices behind a PLC. Unexpected communications. So this is more from an IoT perspective. We're seeing Dropbox communications into a badge scanner network using SLAM protocol. We see a light bridge up there. In this case, we have an iPhone, a television, a Roborock vacuum, random things being picked up on a corporate network that probably shouldn't be. This is Philips and Televue. So this is a medical device network. We see Philips and Televue at HL7 communications, but we noticed that one of the Philips and Televue panels there, which is it's a patient monitor device, has an HTTP communication out to another device in the network. Maybe normal, but worth looking into. So we start to highlight that there. So we have the HTTP communications going to a patient monitor. Unknown processes or misconfigured devices. So this is a screenshot. Again, this is from an implementation. I believe this was in a hydro generation facility. And we see a bunch of new function codes for one of the existing protocols that they're using. So DMP3 is a very common protocol for industrial communications within substations. But it's not something that you would typically see a wide range of function codes. You'll have something specific that's being used for that process. And in this case, we see a scan of function codes, which could be indicative of a misconfigured device. It could also be indicative of an attacker that's in the network trying to understand what processes are available to them. Networking issues. Again, not really a cybersecurity concern, but these are networks that aren't typically being monitored by standard tools, as I've said a couple of times, so these types of things can get missed. They also don't get updated very often, so the cables may have been laid 20 or 30 years ago, and it could be basic cable degradation. It could be there's too many packets on the network. These are usually 10 meg or 100 meg links. So this example, we just see an example of a communication link there that has a retransmission rate of, where's it at? 90.9%. So a TCP retransmission of 90.9%. Could be a bad cable, could be something going on with the host or the network card, but something that we weren't looking for from a cybersecurity perspective, but we were able to help a customer uncover a problem that they wouldn't have been able to identify otherwise, because you can't use Nessus scanners and tools like that within these industrial networks. There it is. Another example of serious network issues, this is just an availability report. Hopefully on most communication flows, you're going to have availability closer to 99.9999%. Maybe it's not going to be perfect 100. This is just showing that the availability of this connection for Oracle last week was less than 95%. Unencrypted and weak credentials. This is a very common thing in industrial networks to use unencrypted protocols. What we do worry about sometimes is when we see very weak credentials, default credentials, or no credentials being used on communications within those unencrypted networks. Abnormal device operation. So this is a Siemens S7 PLC. And what you see there on the bottom graph is there's a long period there where there's not actually any changes happening to the variable. And then finally, something that's not unheard of, probably not in all of, not something we expect in any of our implementations normally, but I would say, it happens. Maybe one or two that I've been to, and I've heard a few from the others, as we come in and the networks are actually already completely compromised. And we plug the box in and everything starts to go red. We've been walked out of environments before for this. Saying, thanks for coming, thanks for showing us this, and you can come back in a couple weeks once we have it cleaned up. In this case, we have alerts for Dragonfly malware. We have changes to the process variables. We see SMB remote code execution attempts. And again, this is all very basic things that you would hope that in an IT environment is pretty easy to pick up and monitor, but in this case, operational environments, we don't typically see that. IoT devices, you're not typically looking for it. So it does happen that we go in, we plug the box in, and everything just starts to go red. So I think that's it that I have for slides. Do you have any questions? Yes. Yes. Yeah. And actually, if anyone's interested, I do have a live demonstration of the product at our booth out in the front. Again, it's very simple. I'll play a PCAP. In this case, the packet capture is coming from a hydroelectric generation facility. We'll show the, I think it's Modbus and IEC 101 traffic, or IEC 104 traffic, how we use the deep packet inspection to identify devices without actually communicating with them. How we do the vulnerability identification, but yeah, so it'll build a network map, it'll build out an asset list, and it'll build out a full network communications list just based on the packet capture. Any other questions? Yes. Oh. Sorry, I've been losing my mic the whole time.
Yes, there is one question. The question was, can you put on the screen? There was about differences between IoT and the OT and this IT environment. What is the key differences between the security between this one? Yeah.
Yeah, for sure. So the main difference is just in the communication protocols. Most IT communication protocols are well known. They're pretty basic. It's the same protocols are used for a lot of different applications. In IoT networks, there's still some use of basic IT protocols. You still see HTTP, HTTPS, but you start to get more unique protocols. When you get into industrial, it's like the Wild Wild West. There's hundreds of protocols. In some cases, we'll see dozens of protocols within a single environment, even across implementations of the same vendor. So most of these protocols aren't known to common IT tools. Most of these protocols are very kept close to the vest by the vendors. They don't like you accessing them. They won't give you material on how to monitor them. We have to reverse engineer most of the protocols directly in order to manage them. In some cases, they're unique to an individual facility. We do a lot of work with, for example, power generation facilities in Japan, where every single power generation facility has their own protocol for distributed control environments. So that's probably the biggest difference. There's also the fact that these environments aren't updated very often. Again, I said earlier, you'll still see Windows XP, pre-Windows XP versions of Windows operating systems, older networking equipment, unmanaged switches. So it makes cybersecurity very, very difficult from that regard because you're dealing with not just older basic technologies, but also the fact that many of these devices and operating systems, they're not supported by the vendors anymore. They don't get patches, so you have to be really creative in how you're going to secure them.
Thank you, Michael. So I remember that I will always, of course, share the slides. And there was, yesterday we were discussing, and there was one more example related to the malls and the elevators and this one. And so there's cool examples and deployment architecture in each sector, and I will share this later to them.
Perfect.
I think there's no more questions. Thank you, Michael.
Yeah, thank you. Appreciate it.